This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hi, everyone. I'm Jason Morgan, Content Director for Fleet Equipment, and welcome to Fleet Equipment Unscripted. Today, we're talking with Ben Johnson, Director of Product Management for Mitchell 1. Ben, thanks so much for taking the time. It's good to see you.
Hey, good to see you, Jason. Really appreciate the opportunity to be on.
So we are going to talk about two very popular topics right now, ADAS and electrification. And as more of these come into the market, I'm getting the sense that the service needs, the layers are being peeled away. We're starting to understand what goes into these a little bit more. So let's start with ADAS, Advanced Driver Assistance Systems. Where do you see those making the biggest impacts on the service process?
Well, Jason, I think that where ADAS is making an impact, it's an interesting technology, right? Because ADAS isn't a thing. It's kind of an industry created category of all these safety features and, adaptive cruise controls and blind spot monitors and all the other things that go with it. And I think that the difference between ADAS and any other new technology that we've ever dealt with in the past is that you can't not be involved with it. I mean,
Right.
These vehicles, by necessity, having all these sensors and cameras and radar units kind of around the peripheral of the vehicle, you could be doing, in the past, I've seen technologies where people would just say, well, I'm just not going to deal with that. I've got plenty of work not working on that stuff. Let me just keep doing what I do. But today, if you want to replace a radiator or an AC condenser on certain vehicles, you move, a nice little black box out of the way to get to that. And what you just moved was a radar or a camera or some other sensor. And by just the physical act of moving it out of the way, you didn't do anything wrong. You put the new radiator back in, put the box back in place, but you could have affected its static calibration, right? Where it's in it. And if you had a camera looking straight out, just a couple degrees off and 500 or 600 feet ahead of you, you might be looking into an oncoming lane or into the bushes or up into an overpass or something like that. And without even realizing it, you are now in the ADAS business.
Right. Right. Well, and the more we've talked about this, the more I am starting to hear more about the overpass being recognized as a vehicle, right? And you mentioned the radar and the cameras working in tandem. So what can you do to make sure you're making the repairs correctly, then getting ADAS back into the right shape? And what, if anything, I know you all are big on the interactive wiring diagrams, and a lot of this is electronically controlled. How is this all working with the service information you have to provide techs?
Yeah, well, there's a couple of things there. So first of all, you're exactly right. We've heard now numerous reports of vehicles that just stop, like they throw the emergency braking on when they come to an overpass because the camera interprets that as they're coming up on an object. And all this does, especially in the heavy duty market, because a lot of these ADAS features in heavy duty have been overridable, if you will. You can disable them for either the trip or forever. And if the driver loses confidence in the system, that kind of defeats the purpose for putting them on there, right? So we don't want that to happen, and of course we don't want a collision that shouldn't have happened or another bad event. Now, you bring up some good challenges with service, though, because like I said, since ADAS isn't really a category, it's hard. I mean, so we can do the easy thing, right? Hey, when you're getting ready to do something, look it up, which is probably the right answer. But what do you look up? What do you need to actually? None of us have the time to research every little black box that's on that truck to find out if it's something that we need to be worried about. So what we've done is we've actually added in our truck series product and in our light vehicle products as well, an ADAS button that kind of goes through the repair information to look for systems that we associate with ADAS, like adaptive cruise or blind spot monitors or whatever they are. And we kind of collect those in there. So we do say before you go into a job, just click that and it'll kind of list out the components. It'll list out the systems that those components support, and it'll try to list out even when those systems might need calibrations. Hey, if you remove it, you put it back on, it might need a calibration. If you're replacing a windshield glass, might need a calibration, whatever those are. So at least we're trying to give them one spot where they can identify all these systems and kind of do a little research. And I think that's part of it too, Jason, is, as an ex-technician myself, it used to be that we went to service information when either we didn't know how to do what we wanted to do, or we needed some kind of reference, like what the sequence was for the head torque, bolt, torquing the head bolts or something like that. We didn't look in there just for, we knew how to replace an alternator, we knew how to replace a radiator. And, my message to people is you gotta just take the 5 minutes to take a look, because in these newer vehicles with these newer technologies, there might be something there you're just not used to. We're not saying you don't know how to do it, but it's just worth your while to make sure you're not accidentally impacting something that's going to cause grief later, right? So referring to that repair information before almost every job is now not just a nice to have, it's like you must do it. And then relative to diagnosing these things too, you mentioned the wiring diagrams. We have put a ton of effort in wiring diagrams over the last few years. So, if you think back to the, back when I was a mechanic, we had these big brown books that were reference manuals. And if I had an electrical problem, I would kind of open up to the diagram that I was dealing with, and I'd, be peeking around there, maybe taking some measurements on the vehicle, and I'd find some component I'm interested in. I'd bookmark that page, then back up, find something about that component and research it, and then come back to the diagram. Well, we've allowed that now to happen in our interactive wiring diagram, so you don't have to leave the diagram like other electronic systems. You kind of have to say, okay, I want this now. Now you leave it, go research, then you got to find your place again. It's not so easy. So now in any of our diagrams, you can highlight the wiring and the circuit you're interested in and follow that, not only from page to page in a diagram, but from diagram to diagram now. And if you find a component you're interested in, you can just click on the text by that component, and it'll bring up a little pop-out box that says, hey, what do you want to know about it? How to repair it, where it's located, whatever it might be. And then when you're done with that, you just click back into the diagram and you're right back where you came from. So we are really trying to arm the technician with, we want to keep them efficient. When they're in my product, they're not theoretically making money. We want them in my product, find what they need, get back out, get under the hood, do what they need to do. But we also want to make that a very fluid experience for them. And that's what we're striving for.
Right. Well, and it's a moving target too, because you mentioned, talking about some of the ADAS systems, even just recently, I was at a product launch looking at a new powertrain, and now they have the lane keep assist, where it kind of helps you hold the lane, right? And there's an electric control box on the steer axle, right? So that gets bumped, or if you unplug it to do something, you forget to plug it in, something like that. As you pointed out, it's going to be ever evolving, and these are safety critical components that you want to make sure you have a handle on. Speaking of the electrical systems, of course, the other big thing we're talking a lot about is EVs. And I know, look, every time I ask the EV service question, we don't really know. More coming out as more EVs are getting in the market. So I'm going to put it to you. What are you seeing as far as EV service? It's early days, but any headwinds that fleets should be aware of?
Well, you're right. It's an interesting question. It's like you can't go to an industry event now without being bombarded and questioned and what your thoughts are. And first of all, I think it's obvious they're coming. There's a lot of debate about the actual ramp up and when they'll be here. Especially on the heavy duty side, we hear a lot about all the things that have to happen to really facilitate them. Like, what does a new truck stop look like? And you pull in for the night, and standardization of charging ports and locations and things like that. But as far as the actual service of them, they're super high voltage electrical vehicles. So what we all have to get our heads around is that there are still an awful lot of components in these things to go bad. There's some very advanced cooling systems now where, we don't have engines to make vacuum to do anything anymore, and we don't have engines to run an alternator to do anything anymore. So as soon as you're off the grid, you are in discharge cycle. And we still have 12, 24 volt systems that manage 90% of the cab, 90% of the truck. And then we have the high voltage electric, which primarily will drive propulsion and perhaps the high voltage HVAC systems. And, I like to pick on it. So it's just everything on it is like, if you don't have a fair background in Ohm's law and electricity and using wiring diagrams, you need to shore up on that stuff, because not that you don't need it for the standard combustion engine with all the ancillary components like ADAS that are being put on it now, but for electric vehicles, it's just going to be paramount. And, I think it's paramount that, you understand and trust those high voltage wires, which are all nice and blazoned with that orange colored,
Yep.
stuff. And, for techs like me, I mean, I probably broke the cardinal rule back in the day. I always used a 12-volt test light, and I'd probe wires to looking for voltage, which you probably shouldn't do. You're breaking insulation by doing that. We didn't know any better back then, but man, you do not want to do that on one of these orange leads, because now you just opened a really open path to ground for very, very high voltage, and it's going to find that, whether it's your hand or some other thing that attracts it, kind of like a lightning strike.
Right.
But other than that, Jason, I think that there is a lot of hype around HV vehicles, and if you do, if you respect the electricity, if you wear your PPE, your nice rubber gloves that are associated, if you've got a digital voltmeter that is rated for high voltage service, and I'm told there's a level 3 now rating for these things that they should handle for making sure they're safe. And I guess basically understanding when the vehicle's in the mode it can be serviced in, because we're all used to hearing the clatter of a diesel engine, and knowing that if it's running, we shouldn't get under the hood without making sure it's disabled. But these things are ultra silent, and you want to make sure it's in a service mode. And if you're going to be actually dealing with the high voltage areas, make sure you've bricked it, if you will, disabled that high voltage system. And that doesn't always just involve pulling that grip plug. It involves doing that and waiting some amount of time for supercapacitors to wind down and other things, just so you don't get hurt. But other than that, it's basic electrical diagnosis for everything else. I mean, if you understand electricity, you have a much broader vehicle now of electrical potential diagnosis.
Right. Well, and going back to your point, I love the point of just doubling down on your background and expertise in electrical systems, because I mean, yes, we're aware of it, but to your point, the diesel technicians, even for a layman like myself, and talking about the equipment, we've talked about horsepower forever, and now I got to talk about kilowatts. Like, it's a different world. It's a different world that there's some similarities there, but as far as the powertrains go, I mean, it's just night and day, and you have to know the electrical world inside and out. To your point, it can be a safety critical aspect too, that you can't just go poking around in there. You got to take those precautions. And we've seen, early days, I was actually just at a event with Volvo trucks, and we got to look behind the scenes. NFI was running some of theirs, and it's very cool. But in that regard, a lot of dealers, OEMs are certifying their dealers first. But then they are working with the fleets on safety precautions and that kind of thing. So it's kind of a learn as you go, and until we get to the mass kind of consumption of electric vehicles, fleets have to be careful. Don't think you understand it just because you remember some of your electrical. You have a really really good working understanding of the system.
Right. And, don't forget that there's still an awful lot of mechanical components in there too, right? And there's, this torque still has to get to a drive wheel or a few. And, I don't even think we know yet what the long-term, how this immediate torque that these electric vehicles can throw at these components, and especially in the heavy duty world where they're hauling huge payloads, how all that stuff's going to respond. And, and I touched on, the other systems other than just the propulsion system. We now have, we have HVAC systems that have high voltage, 3-phase electric variable speed scroll compressors, because they only want the compressor to spin up to produce as much output as it needs, so that it doesn't drain any more than it has to on that high voltage power supply, right? And so, and they're heat pumps, because you don't have an engine to heat coolant anymore for a heater coil. So they have to reverse cycle to heat as well as cool the cabin. And they have the responsibility in many cases of keeping the battery modules at the right temperature. We talk about megawatt power charging power supplies and things like that. Well, trust me, nothing's going to be throwing 1 million watts into a battery pack that's running at 180 degrees. First thing that thing's going to do is query the onboard system, say what's the temperature, and the cooling infrastructure to focus on that battery module and get it down. I think they like it between 70 and 100 degrees and around about that range, so that it can accept the wattage, the amperage, without creating a thermal event, and without significantly, killing the life of the battery. So a lot of, and all these things are, I don't know that much on the heavy duty side what the failures have been yet. I don't think they're out there enough yet to really know.
Yeah, we don't.
But I know
We
that
don't
in
know
the
yet.
light vehicle side, like Toyota Prius has had this for a number of years now. We're seeing a trend where, between 100 and 150,000 miles, these compressors are dying, and there's like $1,500 a piece just for an electric compressor. So,
Right.
there's going to be plenty of other types of work that are going to be necessary here that we're just, like you said, we're going to learn it as we go.
Right, right. Well, it sounds like then you and I will have a lot to talk about here coming up. So I appreciate you taking the time. I'm sure I'll talk to you again very soon.
Absolutely, Jason. I appreciate the time.